Hello, thank you so much for joining us today. And in this video, we want to look at how we can solve a geometric progression problem. We shall use the GCE 2017 Mathematics Paper 2 and try to solve the question under geometric progression GP. But before we can do that, we are going to begin with the first part of question 2, which is the question asking us to simplify the given expression as shown here. So for our solution, here is what we need to do, or solutions. So we want to simplify the expression. So this is for part A. We have m squared minus 1 over m squared minus m. Okay, so how can we simplify the given expression? So let us look at the very expression carefully. What can we say about the numerator to begin with? So this numerator part is what we call as a difference of two squares. And because of that, we can express it into this form. So we are going to have m squared minus 1 squared over, again we can check what we have under the denominator. Is there anything that can be done? Yes, there is, because we have m, which is common throughout the expression. We can factor it out. That will leave us with m outside, and inside we are going to have m minus 1 inside of the brackets. Again, the numerator part can now be expressed as m minus 1 and m plus 1. That is the implication when we say it's a difference of two squares, which of course is going to be divided by m, open the brackets, m minus 1. Wow, and then we can now see that there are some similar terms both in the numerator as well as the denominator, which can be said to divide, and then this will leave us with m plus 1 divided by m. Can we simplify any further? No, we cannot. So there ends our simplification for part A. Okay, we can now move our attention to question B, which is the geometric progression question. So the question reads, the first three terms of the GP are 6 plus n, 10 plus n, and 15 plus n. Find the value of n, that is for the first part. How can we find the value of n? So here is what we need to do for us to get the value of n. So we are going to use the concept of the common ratio. We understand that common ratio R is gotten by dividing the second term over the first term, which is the same as dividing the third term by the second term. So we shall use this part of our formula from the common ratio. We know from the information that we have been given, we have our first term equals 6 plus n, our second term is equal to 10 plus n, and our third term is equal to 15 plus n. So it's just a matter of us now substituting in the formula that we just created here. So for term 2, I'm going to substitute by this. So we have 10 plus n, which will be divided by term 1, which is 6 plus n, equals term 3, it is 15 plus n divided by term 2, again it is 10 plus n. And because we have two fractions, we can do the cross multiplication and then simplify. So this is what we are going to do, and it will give us 10 plus n, 10 plus n when we multiply the diagonals here, which will be equal to 6 plus n multiplying 15 plus n. Okay, so we can multiply and then simplify. So when we do 10 times 10, we are going to have 100. 10 by n plus n by 10, we are going to have plus 20n plus n times n will give us n squared, which will be equal to, we again multiply 6 by 15, we are going to get 90 plus 6 by n, we get 6n, again n by 15, we are going to get 21n plus n squared, which will come from n times n. Okay, hope we are moving together. So now at this stage we can do the correction of like terms. So when we do so, we are going to have n squared minus n squared. Then we have positive 20n minus 21n. When it moves from this side to the other side, the sign is going to change to the negative, which will be equal to 90 minus 100 also, which is the additive inverse of positive 100. So this and that goes, giving us a 0. Then positive 20 minus 21n, we are going to get negative n, which will be equal to negative 10. The question is asking us to find the value of n, not the value of negative n. So we can simply multiply everything by negative 1. So negative 1 times negative n, we're going to have positive n equals negative 1 again times positive 10, we get positive 10 as the value of n. So that is for the first part of question 2b. We have managed to get the value of n. So part B now is asking us to find the common ratio. So common ratio, abbreviated by the use of R. Letter R is equal to second term divided by first term. If we want, we can use third term divided by second term. The solution will still be the same. So our R is going to be, so our second term, this is what we have for our second term, to be 10 plus n. Now we know the value of n as 10, so we shall simply substitute, divided by the value of t2. Yeah, this is supposed to be t1, sorry. It is t2 divided by t1. So the value for t1 is going to be 6 plus n, again n equals 10. So the value of common ratio is going to be 20 over 16, which can be simplified to 5 over 4 when we divide both in the numerator as well as the denominator by 4. 4 into 20 it is 5, 4 into 16 it is 4. So that is the value for the common ratio. Okay. The other part of the question is asking us to find the sum of the first 6 terms of the sequence. So this sequence that we have, we need to find the sum of the first 6. The sum of the first 6 terms. How do we get the sum of the first 6 terms? So that is under part C. We can get the sum of the first 6 terms by employing the use of this formula. Sum equals A, open bracket, R power n minus 1, close brackets, divided by R minus 1, where In this case, we use this formula if the value of r is greater than 1. So now that we know the formula that we can use, we can simply substitute. We want to find the sum of the first 6 terms. So the data is that our n will be equal to 6. Our a will be equal to 16. Simply put the value of n here and then we add. So it will be 16. That is the value of our a. So we can now substitute. Sum of the first 6 terms will be equal to 16. Then we open the brackets. Our r, we know it is 5 over 4. 5 over 4 power 6 minus 1, close the brackets, over